Okay, here we go. Rules today. We have f plus g, so the derivative of f plus g, which we would write like this, is equal to f prime plus g prime. Now you've already actually used this rule. If we have a function, say f of x is equal to x squared plus 3x, what is the derivative? 2x plus 3. So you're using that rule. You're just simply taking the derivative of each part, correct? So it works the same way for subtraction. It's f prime minus g prime, but it's different for multiplication and it's different for division. That's where we have something we call the product rule and the quotient rule. And the product rule, so we had the power rule the other day, which we've been practicing, which we call the shortcut. We also have the product rule and we have the quotient rule. The product rule looks like this: f prime g plus g prime f. You take the derivative of the first one times the second one left alone, plus the derivative of the second one times the first one left alone. Just switch them and put a plus sign in the middle. You okay with that? If you can remember the product rule, you can remember the quotient rule. It's the same thing, except there's a minus sign. And you divide by g squared. That wasn't bad, right? I mean, it's basically product rule, basically the same thing as quotient rule, but you put a minus sign and g squared. Mace is getting upset about this. You can tell. He's like, he was fine until I put the g squared. Okay, all right, sorry, pal. All right, okay, here we go. Flip it over right here. So we used to, in order to take the derivative of x squared over x minus 1, we used to have to do that thing on the board, right? And we don't want to have to do that. We want to be able to use the power rule in combination with the product or the quotient rule. So this is going to be a quotient rule problem, and here's how I find the derivative. F prime of x is equal to, I take the derivative of the top. Remember, the rule says f divided by g prime is equal to f prime g minus g prime f all over g squared. So f is the top function. What's the derivative of the top? 2x times the bottom left alone. X minus 1 minus the derivative of the bottom. 1 times the top left alone. X squared all over the bottom squared. Yeah. I'm going to combine some like terms here because it's pretty simple to do so. Yeah. So f is the top function. So it says I take the derivative of the top. The derivative of x squared is 2x. Times g. G is the bottom function. I leave that alone. Minus the derivative of the bottom. The derivative of x minus 1 is 1. Times the top, left alone. Then the bottom squared. Okay. I'm going to simplify this a little bit. 2x squared minus 2x minus x squared all over x minus 1 quantity squared. What's 2x squared minus x squared? Squared minus 2x over x minus 1 quantity squared. Oh, 1 times x squared is just x squared. So that's my derivative. A lot better than doing that, right? No big deal. Okay, I need you guys to buy into this piece right now. I'm teaching you the product rule and the quotient rule. But the problems I'm showing that you're using it for, you're not really going to use them for these type of problems. You're going to use them for these type of problems. F of x is equal, don't write this down, e to the x times sine of x. Okay, you're going to use it for those type of problems. I mean, yeah, A, you would use the quotient rule. But B, you're never going to see a problem like that. They're not going to put two binomials multiplied together. They're just going to write it out as a polynomial. You know what I mean? Your book is not going to give you a complex fraction as a problem. They're going to give you an actual function. Nobody leaves it like that. See what I'm saying here? So we're practicing it, but these examples aren't very practical for what we're going to see in the future. All right? The real types of problems that you're going to need to know how to do are on the next page. This right here is just for practice. So don't get mad when we don't simplify this. We're just trying to practice the rule. So f prime of x, do I use the product rule or the quotient rule? Product rule. I take the derivative of the first, which is 4x. Times the second one left alone. Plus or minus. Plus the derivative of the second one, 10x minus 2. Leave it. I know that makes you angry, but the fact is, you guys, if we multiply this all out and combine like terms, who cares? It would have been the same as multiplying this whole thing out and then taking the derivative of it, right? For example, when you take 2x squared times 2x or 5x squared, you get 10x to the fourth. And when we would take the derivative of that, we would have gotten 40x to the third, correct? So, well, yeah, no surprise. You're going to get, you're going to get a 20x to the third and then another 20x to the third, which is going to make a 40x to the third. So our goal isn't to necessarily see that we can multiply everything out. Our goal is to see that we can do the product rule correctly. So we're leaving it. We're done. Okay. Let's look at D. Product rule or quotient rule. I don't like C. Product rule. So what's the derivative of square root of x plus 3? The quicker you can come to this memorization piece that the derivative of x to the 1/2 is 1 over 2 roots of x, because it comes up a lot. Everybody see how we go from there to there? 1 over 2 roots of x. There will come a time where it will just be second nature to you. So we got 1 over 2 roots of x times the second one left alone. Plus or minus, plus, what's the derivative of the second one? Times the first one left alone. Done. Just leave it. Just leave it. If there was like a common factor you could take out, that would be different. But there's not. Okay, leave E. F, do you think it's product rule or quotient rule? It is the quotient rule. And it's really nice. What's the derivative of the top? 0 times the bottom is 0. So nice that is. Minus the derivative of the bottom, all divided by I apologize because I'm pretty committed to showing you guys where all the formulas come from, right? I always do like, okay, let's prove this formula. Let's show the picture of where it comes from. I haven't done that for the product rule or the quotient rule. I haven't done that. If you want to see that, look in your book, or we can sit down someday after school. It'll be a really good time. All right. So nothing cancels here, but I am just gonna, just because I want to, I'm gonna clean this up a little, just because I have a negative, and a negative is gonna make a positive, and I'll distribute the 3. So I'll get 36 x to the third um, plus 12x minus 3, because it'll switch to a positive 3, right? You got minus a negative, it'll switch to a plus 3. At the bottom, 3x to the fourth plus 2x squared minus x quantity squared. So again, it's nice to use the quotient rule as opposed to something like, that. So all right, let's get to the real problems, and hopefully we finish before lunch here. You guys can then come back and use the whole rest of the time for work time. All right, so these are the two type of examples that you really need to be able to do for your test. And I would say, just to give you an example of what I want you to be able to do for the test, I think problem A, really good example, and problem F, those are two really good examples of when, right now it's like, okay, we would definitely use the quotient rule. Does that make sense? Um, and then the other examples of stuff that you would want to make sure you can do for the test would be like example 3 and example 4. These are good problems. It says given f of 4 is 3, f prime of 4 is negative 2, g of 4 is negative 5, and g prime of 4 is 2, find the following. And that looks really confusing right away, right? So let's just see if we can write a rule and then plug something in. It says f minus g prime of 4. Well, our rules that we gave ourselves from the other day say that we take f prime of 4 minus g prime of 4. That's what I wrote today right on the sheet, right right when we got started, right? All we have to do is take the derivative at each spot. What is f prime of 4? It tells us here that it's negative 2 minus, what is g prime of 4? 2. When I subtract those, I get negative 4. No big deal, right? But when people see this, they panic on the AP exam because, it doesn't have what appears to be a polynomial or something, right? You don't see the function rule. Okay, how about f plus g? I would do f prime plus g prime, correct? So I'd have negative 2 plus 2, which is 0. Now, what do you think the mistake that people make for letter C is? Yeah, they just do f prime times g prime. No, we have to use the product rule, which is f prime g plus g prime f. You need to memorize the product rule and quotient rule. What is f prime? Negative 2. What's g of 4? Negative 5. Plus, what's g prime? And what's f3? So I got positive 10 plus 6 is 16. So the derivative, the two functions multiplied together is 16. How's that? Okay, and the last one, again, some people would just take one and divide it by the other. So you look f prime of 4, negative 2, divided by positive 2, they get negative 1. We can't do that. We have to use the quotient rule. F prime of g minus g prime of 4, I'm sorry, g prime f all over g squared. So f prime, negative 2 times g, -5. So it's like what we have over here, except we're going to have a minus sign. And what's g squared? 25. We got positive 10 minus 6 over 25. So we get 4/25. Can you handle that? Yeah? Okay. Last two examples. Oh yeah, I'm sorry. I apologize. This is something that people haven't been as well prepared for the tests in previous years, as I've assigned stuff for examples. So I added a couple. So if you just want to write this on there, it shouldn't take up a lot of space. You should have some room. I think we made a little drawing below there. If you got about a quarter of a page, it should be fine. So when we started out in calculus, what was the first type of problem that we wanted to solve? We wanted to do what? What was the big idea that we were looking for? Slope of a line at one point, tangent to a curve, right? Well, we come right back to it. Write an equation for a line tangent to a curve at x equals 0. So I see that word, write an equation or phrase, write an equation for a line. What two things do I need? Point on the line and slope. Good. Point on the line, I'm going to have x is 0. How do I figure out y? Plug it in. When we plug in 0, what do you get in the numerator? Denominator? 2. So 0, 0. It says it's tangent at x equals 0. To find the slope, I have to take the derivative. Slope and derivative are the same things. F prime of x. What rule will I have to use to find that derivative? Quotient rule. Derivative of the top. 4 times the bottom. X to the third minus x plus 2. Minus, what's the derivative of the bottom? Times the top. 4x. Over the bottom, x to the third minus x plus 2 quantity squared. Your gut tells you that you should simplify that because you're used to doing that in algebra. But does the problem ask us to give a simplified version of the derivative? It simply asks us to find the slope. So all I have to do is plug in what for x? Just plug in 0. I get 4 times 0 minus 0 plus 2 is 2 minus -1 times 0 is 0. This becomes 0, right? Over, plug in 0 in the denominator, I get 2 squared is 4. So I get 8 over 4, which is 2. Is that enough information to write your equation for your line? Yeah. We have y minus y1, or 0, equals m2 times x minus x1, which is 0. So you get y equals 2x. It's pretty straightforward, huh? So see, we didn't have to simplify. We just used the quotient rule in order to find the equation for the line tangent, which is a pretty impressive thing to do. So we try again. Point on line and slope. When you plug in 0, what do you get? 3 times 1 is 3. Yep, very good. Every single AP Calculus exam I've done so far, I've done about 5 or 6 of them. I'm doing more this weekend. I see problems exactly like this. They like to do this, okay? You got to figure out the point. So, okay, that's 3. And now we'll do the slope. So I got to use which rule? Product rule. F prime of x is, what's the derivative of the first one? Plus minus 6 times the second one left alone. Plus or minus? Plus Go to backwards. Okay, what are you doing now? You're taking the derivative of the second one? 2x minus 1 times x to the fourth, 5x to the third, minus 6x plus 3. Good. So again, it looks bad, but it's not bad because you just have to plug in 0. Plug in 0 here and you get negative 6 times 1. Plus, plug in 0 here, you get maybe 1 times 0 here, you get, isn't that a nice problem? Negative 9. Close. You have a y-intercept of 3. So y equals negative 9x plus 3. You would write that in slope-intercept form. Okay, good work. The assignment looks like it's long. It's not. It goes pretty quick. Don't need to really simplify, as we talked about. Simplify for 23, 24, and 27 through 30. 51, 53 are just like what we did, and 58 was that problem where you weren't given an expression. You were just given f of 4, g of 4, f prime 4, g prime 4. Come back, you have the rest of the hour to work. Monday, work day, the entire day on your study guide. I'll post the solution keys quickly, but I really don't want to. I want to do this test on Tuesday because I want to waste any more time. We gotta hustle. All right.